That your colleagues.
Be doing work on the
Calling David. Hi, David. So I'm gonna share the slides with you. I'll just try to say share screen. Okay, you want to see the face instead of the slides. Okay. So here is for David. Okay.
Oh, here is not.
Oh yeah, the voice is pretty.
Okay, so we have a
Okay.
so what we do with the Zhou use
Thank you everyone for being here. Thanks so much for my committee members for the support. So my favorite topic is engagement in multimodal interactive conversational. So we care about engagement. When we talk about the system, we're talking about talking with a human. So here we're trying to incorporate engagement, the notion of engagement in designing the system, and also in their actual evaluation, we will show how engagement would affect the user experience. So we have, I'm very lucky to have all my committee members here. Alan Black, Alex Ericki, Lee Morency, and Dan Bofa, and David Littleman. First of all, we talk about some of the current dialogue. All know the AT&T and telephone-based customer service. Everybody hates it, but it has been there for a long time. And then the Jupiter, which is another project from the government funding, and the Doppler communicator, which is actually something that brought all the researchers together to work on this airline booking. Then we have the famous Let's Go Bus based in TMU, my advisor Ellen and Maxine are speakers. Then we have this Cambridge Information Gallery, which is famous for restaurant research. And then now when we come to the new area, we're coming to the company dominated perspective. Theory from Apple as the first one that brought dialog system to everyday life. And then we have Google now from Google, which has the predictivity. So, and then we have Microsoft Cortana. It is having this notion of saying that it can talk about anything. And then we have this Echo from Amazon, which is an embedded device. And recently, last month, Facebook came up with the M. So we can see that from research community to the industry, dialog system not adapting to user for any reason. So my thesis proposal here comes to motivation. So what we are as a human, when we talk here, we are not the conversation has a task. We are trying to communicate something. But on the other in parallel, we have this channel link. So we are trying to build this bond between us. So instead of requesting information or providing information, we're trying to use conversation as the social bonding, social connection between us. So with the advanced multimodal sensors technologies, we can actually sense the human internal state of the prediction of the internal state, try to adapt to the user. So the dialog system is now we think can understand and be taught with social intelligence, beautiful in order to make the conversation natural, increase so in order to improve user experience. So I have a couple of questions. First of all, what is qualifying engagement? And second is, how can we encourage user engagement using the magic? Third is, what are the conversational strategies that can improve user engagement? And then the last one is, how to design policies to adapt to user engagement in both non-task and task that we can have a more natural. Let's talk about some of the related work. So there are three parts of the related work that I will go through. First is multimodal sensing, and then is multimodal dialogue. Finally, what is engagement? So we all know that multimodal social signal processing is a new area. A lot of there's a lot of claim that the social intelligence is the key for humans to succeed. So can we make the machine to be aware of the surroundings, to be aware of the connection between humans in order to make it succeed? So first of all, we look at how humans perceive the verbal and nonverbal behaviors that is contributing to this social intelligence. First of all, the proximity, how close has differences from how close your relationship is. We can clearly see that people on the picture don't like each other. Picture the history is actually a signal that is sending to you about their relationship. Also gesture. Facial expression, which is more complex actually is also the parallel. So we're not saying that non-verbal is only about the visual. It's also about the audio, how fast you speak. All of them are contributing to better understand human connection. So after we talk about all these really advanced techniques, then let's see how our dialogue. So Dan developed their actually getting the same microphone. Multimodal input navigation helps you to fix the all ones when you're taking the turn. You don't want the developer to yell at you. You want the user use the dialogue. That's our navigation system. Listen our really rather than. So, and this also we have this in-house companion robot. One have a robot that roams around in your house, and their sensor like system and interact. And we also have virtual human interviewers for healthcare ICT virtual interviewer to help you get a sense of. Now we have a system of the building We have this long-term engagement relationship, which means that um, this engagement is not only about one term, but it spans over years of lifetime. We also have locally we have 15 self-groups that developing a rapport agent as well. There's the differences between them is from 1 to 5, all of them are task-based and very specific domain. It's really hard to generalize extensively. And 6 and 7, although it is the notion is to have this engagement of bonding, but the system is still explicit language agent. They still follow certain procedures. So, in my business, we're trying to advocate the non-task-oriented system. So that the engagement knowledge we learn from can be transferred and adapted to other. So, we talk about engagement a lot, then we have to define it in order to actually study it. So we adopted the definition for engagement is the process by which two or more participants establish, maintain, and end their perceived connection during interactions they jointly undertake. So we think engagement is a process of one is so there are other people that define engagement differently. There are people saying that it's the goal of being. There are people define it as the aim. So, especially when we also develop the computational methods for engagement. Find that incorporating multimodal information is better than use there's so many distinctions and one of the multimodal and engagement. Both contact and contact are so there are several things I want to talk about. First of all, for the non-concurrent analysis, talk about the interesting all that make all their research happen. Then we want to talk about their data analysis and engagement data. Then we want to talk about the computational multimodal engagement. Then we talk about strategy. And then in the end, we try to talk about the proposal how to design how to do the evaluation. And other part is the experience of think that it's learning the amount of knowledge to doing transfer the knowledge. So we do this inside of the we want to transfer and not first of all, about if they're not learning about that the goal is like to want to make humans then here's a video of and this is a of their base model, the TikTok, without taking from model. See that how many times there is room break. So when we design the system, first I try to deploy the initial TikTok. But previously, a lot of people use this as well. We're not doing that. A lot of people use want to say that we just really want to really analyze the human communication. Our previous person that we were talking to about the real automatic. So what we do is try to do it export data and try to analyze the data to then discover the system using building the strategy and deploy the agent. Means that a lot of people use some of the yeah. Sorry about what you're designing. You don't know about the balance. A lot of people and what one thing one period is using computational methods. We also understand there it is very always a serious design where there's an so first of all, this is a big diagram. I would go through a little bit you're doing all things just after you have the text, you go to the next layer to understand something. So we're there all the things, and then going to which is which is sort of dialogue. Dialogue integration is not necessary before we try to achieve that based on the source. And maybe then we don't have to return the speech. Are we able to say that our balance? The people is actually very conservative. So once we have the input of the user, we go to the database. So the database is has a lot of data. So once we have the input on the user, then we try to find the response. From that, we have the saying that if the retrieved confidence is bigger, then certain threshold the response is lower. Lower than 33, that it's counted. become, um, so this is the basis of the, there's no different. So the next one is place generator. They have work service. So basically, we talk about the space say that we care about engagement. So one of the interesting things is that previously we only have been giving them together actually. So let's all again. So we say that we next thing is that we're gonna talk about engagement data. So first of all, we have to TikTok, everyone wants data to analyze how this is, what are the improvements, and how can we do the engagement. So we recorded 24 interactions, 5 minutes each. All of them are very kind of mixed ethnicity and gender. So we have another database with the all the universities that we offer the students. It is also a unprecedented annual conversation every day. We have two data sets. And we say that how do we get the so we once again the definition from the designer. The annotating unit is conversational. For teacher and space conversation. So the conversational unit is defined by basic the teacher annotator agreement is like one of the reasons is that we have a very and one important thing is that once we have two it after we after the student after the participant with the treatment, we record the data and then we bring the data back to the and we also utilize a very expert in they're asking that they give me the instruction saying first if you're have this person data we navigate or this is the opposite enough the three three interviews this could show that there are differences between churches and groups. So some participants rate their engagement consistently higher or lower than experts. This is human nature. People have different calculations of how engaged you are. There is some of say that we're not saying how long not this or how long not this. Because we're doing this conversation there. So yes, we have dialogic features, which is, for example, like the length of the conversation, and speech on the which is how fast you're. So one of these, now we have the features semantic labels, and we want to use some of them now. One of the things that we use is a user correlation. One is to use how behavior features are correlated with engagement. We have two data sets. One is the human, the other is the human machine. They're all about everyday topics. So especially for the human machine data set, we have two sets of features. One is manual features, like manual labels, for example, like transcription or annotation. And the other is automatic features, which are automatic prediction of the number of verbal and nonverbal behaviors. So we found some interesting results. Basically, the more words you speak, the more engaged you are, no matter your the faster you speak, the more engaged your speaker, the more engaged you are. So you can see that the author correlation number is pretty small. We're not saying that behavior is highly correlated with the engagement. We're saying that the behavior is somewhat correlated and telling you something about this association. We're not saying that we're using this particular feature to predict engagement, but we're trying to use this analysis as something to understand the behavior, trying to select the features that we can incorporate in our machine learning model. So the acoustic nonverbal behavior, the louder you speak, the more change in your speaking ability, the more you are engaged. And then the linear and some visual nonverbal behaviors, the more you smile, the more you laugh, the more you disagree with each other, the more engaged you are. We didn't find significant in head nod, because head nod is something that is more than just repeat. It is also a signal of knowledge. So it is really hard to choose the part of function of the head nod to get actual engagement. Dialogic behaviors, we find the longer you are in the conversation, the less engaged you are. You get bored after talking to the system or human growth. Then the speech also has a different demand for human. Find the faster you respond to a human partner, the more engaged you feel. But but there are certain glitches of the system that actually makes it harder to see what is the effect of constant engagement. There's sometimes the system, because of the noise, the ASR is the ASR didn't answer, so the system has to either repeat. So there's no response time needed for you to repeat the sentence you've already said, but it doesn't really mean that you're engaged. Manual is the manual label, and automatic is automatic. For example, manual means that you can just, for example, you can like your absolute machine. Automatic the system sees it how long it takes. Yeah, which means that um, the automatic system, for example, when you're repeating something, you missed the previous term. So you think it's a long time for it to respond. So actually, you're not engaged. So because of this system perceived annotation, the system perceived behavior, the real behavior that people naturally look at. So we also have this interruptions and interruptions. You have operator interruptions, which is to finish each other's turn. And we have also disruptive interruptions, which try to steal this time. So there are two effects of interruptions. So a summary of the things that we found is comparison of human and human machine. time, the louder you speak, the faster you speak, the more tension and intensity you speak, the more words you speak, the more engagement you have. The more you smile, more and off, more head nod, more you're more head shake, more you're more engaged. The longer you are in the conversation, the less engaged you are. The difference is when you're talking to a human and when you're talking to a machine, the speak out at time is different. The faster you respond in the human setting, the more engaged you are. The faster you respond to a machine, the differently engaged. So after this, we talk about the analysis that we can use. So we are also saying that after doing the analysis, the correlation analysis, then we're going to decide on what kind of multimodal features I can bring into the for engagement so that we can leverage them in building the model. So we have this nice setting. We figured we have 1, 2, 3, 4, 5 different skills for engagement. So we it as a regression problem. Use regression RPS treatment. And then we have features that we selected that it has some correlation on the information that is bigger than 1. Now under visualization normalization, the metric for evaluation is correlation. And the personalization. We have two parts of the the current and using the current and so the, the route means history content. Or since we are adding figures that have previous history, for example, like 1, you can see that the correlation is so anything um, using content of his information. So we find that after adding more strings together, the performance is better. After different states under service. So for the future prediction, that we are using the current feature extracted to predict the coming trend engagement. This is really important for now. Because you always want to do predictions so that you can save the time for your planning. We find that the performance is less compared it's less significant compared to the your prediction is you're having this timeline, which means the problem is harder than the result. Yep.
Are you using all of the
Yeah, so we're only using the features that are with correlation larger than 0.1. For example, we get rid of the switch. I think I did, but I didn't remember the results. Manual. Yeah. So the human is only the manual. The human machine is so after we have the model, then we can use a strategy. I don't have this thing that saying that if you develop, you found all these beautiful phenomena. Should I just build a synthesizer that is faster, taller, and change or change the speed of the speed and intensity more so that people will be more engaged? No, it's not the case. It is only a phenomenon, but not really the cause of it. We want to know how can we actually change user behavior. So we want to do some strategy. So we're looking through the data that we collected. We have the good where the requirements that are current that have engagement that are higher than previous, more than one TikTok data. We want to look into them and see what happened. Okay. So for the basis, the TikTok is actually find several, we manually look into all these engagement movements and try to categorize them in other subcategories. Being topic, getting together, and adopting famous movie scripts, and then adding human content and making comedy. So we get very strategy by finding instances of each actually. The example is, you like movies? Yes, I do. What's your favorite movie? Participants then engage the technology. And they indicate things to do together. So you come to my friend's party tonight. Now, you guys are losers. Adopting famous movie script lines, for example, using the viewers never fit to lead an army. So they wouldn't fit to group the scouts. What's your idea? The participants think loud and Rich replied that I was actually upset at the ruler about behind the relationship. I don't think he's doing such a good job. So using a lot of praise and adding humor to something. So we talk next. We can hang on after the anthem. What's your idea? I think we should do after the anthem. Making fun of each other. I am not getting into specifics of what job you did. You haven't been treated as it is or teaching. So after we did this discovery, and we think that we have a set of strategies we can have real time engagement sensory. Now have this, and now we want to make decisions. Strategy and applying to the dialogue. So what are the heuristic policies? Randomly selecting engagement and work. The more complex thing is you want to say, how can we do the policy that is complicated? How when to use what? How during the history already used this strategy once. This is one of the goal is to use the global and problems like make sure about the so we have several elements that we use. We have a set of engagement strategies, we have real concepts we use through conversational experience. We have past history that we there's some of the topics that I think I want to go into. So finally, we come to evaluation. So once you do this, you have to prove that the Mr. Laura one thing, the system with the engagement shaping model get more engagement. So one the evaluation method is actually ask for rate engagement of each string and calculate overall systems. Second one is the third group of human observers that interactions with more deep engagement, more effective methods. Say it's one with the harmony. We were another survey study to compare the two one engagement and the other was nothing. And we the third group of human observers after we talk about the whole thing about non-transparent technology, I want to talk about transparent technology. We're using the multimodal is a live stream that is a multimodal dialog, a live stream video from their website. And web-based dialog. We can put more data. So one of the problems with the field is that we always complain about we don't have enough multimodal data. So trying to build a system that is able to use. So we're doing a demo. Hello, Mark.
Tell me why you're interested in this job.
I like the job description, and I'm really I'm doing my PhD in Carnegie Mellon University.
Thank you. Now let's talk about your experience. Tell me more about it.
I have never had a real job. I interned in Microsoft Research in education. That's it.
Now I'm going to ask you a few questions, and I'd like to know what you first. Imagine that a customer calls that a response.
I will always ask the manager. I will ask the manager.
Let's move on.
Here, this is
Oh,
your showcase of
let's
our
imagine a different situation.
showcase of
What
our
would you do?
interview task that we developed into this multimodal policy. So it is basically trying to walk you through the. So first of all, we're introduced a little bit of the policy architecture. So it is also a standard so the most important thing is that so the most important part is that we want to have this engagement component in the dialog manager that can actually use flexible. So we want to expect a system that has engagement modules built in. So we want to have information from temperature sensors. We want to have an open source later. We also want an open source simulator to track the acoustics. And we want to also engagement modules, engagement signals with voice signals. So we generate voice signals dynamically based on policies that they engage engagement strategies and engagement states. So why we're doing this interview training? So the task you have already seen what people interview. The goal is to elicit more information from the users in order to make job decisions, help the user to gain confidence and familiarity in job interviews, also give user feedback about their conversational. So we want the system to have this real-time engagement allow it how the user is how engaged those things, and then we talk about the last thing, like transfer engagement from non-transfer to transfer. All we're going to do that. We all know that for non-transfer, some of the strategies are some sort of some of them are very specific. For example, there's storage and the storage factor and may work for users, may not work for other people. So we think there are several generic conversations you can directly transfer from non-transfer to transfer. Having remote content, giving positive feedback, having a little bit of chatting. Well, for task specific strategy, so we wanted to, we are trying to say that, for example, for the interview, I want to follow up, give more follow-up questions about the user is talking about, and then provide more acknowledgement, more information from you, like cannot and back channeling our detectors data. So we have different users. So for TikTok, we all refer to policy. For the multimodal policy training system, we are going to use Amazon Secrets. We have various technologies. There is from different age groups, different language proficiency. They have very similar motivations when actually all of them have a lot of complexity to their finite. All of them we need certain ways to and also the other thing is about the environment. So TikTok, we also use it in the lab university. Offers multimodal policy. We will put this in church and people can use it at home. Like the things I could be, when I'm talking to you, I could be doing other things while I'm talking to you as well. So how can we try to explain the thing? How can we what the user is using the correctly? And how can we solve the problem of distractions, noisiness, and their recording? The same about actually will be carried out for the text-based system as well. The shaping model, engagement is the frequency override. And also, from the engagement so when we come up with the type, so basically we have so first of all, we
I don't
want
think
to
any of us feel that it's possible. You may have gotten your feedback.
okay. Now we reduce the word. So first of all, we want to adjust and complete the multi-model testing module in the TikTok architecture. Basically, I need to do some refactor and work. And easy to use. Then we want to define the implement engagement policy. And then we want to evaluate it. After that, then we're going to this path-based on design engagement for the manual adjustment. We want to allocate the engagement manual engagement according to the introducing data and design implement engagement factors. Or then design the policy again, strategies and policies, and finally do the evaluation again. So there are several contributions I think it's important to highlight. We want to incorporate engagement into conversation in order to get rid of the boring AT&T on a more engaging we're doing chat and also chatting. Basically, we want to try to approach the goal of Samantha we already did the multimodal dialog framework for test and non-test. We covered computational engagement model, which is augmented conversational model. Now we want to discover more engagement computational strategies, both test and non-test. We categorize them into generic and test. Then we want to contribute a data-driven engagement representation. So in the end, we want to also investigate to see how we can transfer knowledge from non-test in order to get people recipe of how we want to do the use. What we can use engagement models from our study to use something to use a problem. So I also did some other work that I can do in my PhD that is highly related to my thesis topic. First of all, there's one thing we use multimodal to predict the trends of human. We also use multimodal to predict function. We also did our attention adaptive multimodal dialog human robotic interaction. And also did a deep learning work to automatic for non-native speech. I think like data streaming and big data. Here are some references that we can do in the discussion. Yeah.
One question I had, you probably have relevant data of what you currently looked at for your engagement study, specifically when you connected the house and then the other database with only having 7 interactions. I was wondering whether you have looked into the influence of adding, adding more data, or actually the influence of how much data you use for training, whether it still has a positive impact on the correlation figures.
Yeah. That is a very important so definitely with more data, we could give a more robust engagement computational model. So definitely, the TikTok database is ongoing. We're gonna collect more data after we do some of the adjustments.
Yeah, that's very exciting. I was just wondering how, what we can expect when we, for instance, use Basel connection for the encapsulating system, whether this is going to result in more in higher information of the prediction. So far, I think it's pretty well messaging 0.5, but I hope we can even get better if you use more.
Yeah, I definitely think with more data, we could be more robust model.
And I have another question about the commentary trio, where you said you actually removed the name entities before finding the best matches. I'm wondering if you remove the name entities for finding the matches, that makes sense, but then when you create or you actually take these answers and send them back and use them as your response, do you re-enter the name entities or do you filter out the name entities at that stage as well? Or if you have specific names, I think one of you, there was a specific mention that I don't know what I was actually.
Yeah, that is the initial system because we didn't really actually filter out all the name entities. So this is the very initial data. So the current system we have is we just filter out the name entities. We didn't add more more specific names of the system. But it would be nice if we could discuss this.
I love work in that you want to say that whenever there's like something to do, it's helping you with animation. I think we have a example of education and story about it. This is probably the good way we could assist you with, managing all the other amounts of collected data.
Yes, definitely. Thanks so much for David and David for yes, I could use more people to annotate engagement in order to get a more valid annotation scheme and more data annotated on engagement later.
Well, they probably read the right time because I have some more questions to come up.
Okay. Thank you, David.
In the sense of this is
Yeah.
square on the how come prevention
Yeah.
you need to if you have something that's more intense of
Yeah, it's just why I think it's definitely very important to have a robust model so that you know exactly what you're doing so that you can like better. It's the same thing that we did with the attention robust model. So one of the things that we can do is now we have a bunch of pilot crystals, so we did a regression. So the main idea is to make the prediction in the future. But we can also make it descriptive. We say that we just separate the data into high and low, and the results in the middle. Try to do binary classification in order to report the precision report. So in order to assist the prediction, so people have more sense of how to use it. So now actually. Oh yeah. Yeah, I did. I was just talking with LP yesterday that we can incorporate some lexical information, for example, polarity of the words, and um, if we have the ASR, we can use some of the words, for example, more positive words, more negative words. That might be something that would contribute to engagement. Also, maybe some I would say that we need to. So one of the things that we want to incorporate in the system is that the fact section, other fact, we have upper palm, down, and other facial expressions that the other might be able to help with it. Also, again, so also there's something, some work with stated using their speech radar to approve this information to improve
the
Yeah. So you mean that overall engagement and their correlation
I don't have a lot of people when you talk
yeah.
and all this.
There's doing our when doing the energy change from electric people a little bit like higher than lower. It has this bit of like a comparison of cell bodies that are kind of first when TikTok saying so I definitely agree with you that the engagement is a notion which is slowly stopped. Everybody defines it differently. And there are some like really reliably measured using you have different theories of different lenses of engagement that lenses and they can look at engagement. So I think one thing that we can work around is trying to find some objective metrics that is correlated people with their more strong technical backgrounds to say that there's something. So that's why we're also introducing the countering is to that that we have the possible outcomes that to the information. Accurate
If I can interrupt. So, one of the metrics that we came up in the dialogue classes, what is the probability of one more turn taking place? Which seems like a rather objective measure. It doesn't have the big stuff in it. Basically, what's the likelihood of somebody giving one more turn to the conversation? So you sort of capture that in the idea of how long is this thing. I was wondering, I'm sort of butting in with the question here, but I was wondering what your plan on that. Maybe not right now at this instant, but I think it would be good if you could expand from that
yeah.
into something that maybe captures some of these aspects of these heavier things.
Yeah. So you're saying the probability of doing one or probability. Really, eventually it's like a runner if you want to go into
Well, what's the likelihood of that happening in the event
but
itself?
it's very likely to correlate with how engaged you are.
I don't know.
But
But you can measure it.
it's a little bit different, but it's an interesting idea.
So, go back to study.
Yeah.
That we cannot but I'll do that.
Yeah, my main question is actually dance much model good enough. Uh, and also, so, is it by the policy fire? Do you need to do assessment? Uh, so,
Yeah.
in the short term, so
So basically, we engage on knowledge and policy. For example, one production children is really low. Except that they're doing it either
you
in
need to show like or engaging.
okay. Oh yeah, natural and but for the job interview, it's not a really getting the job. It's the system is trying to do it. So the interviewer's responsibility in the job is first to make the people feel good, and second is to make the judgment of whether it's up for the job. So we want to make the balance to have the
And another small question I had was, is engagement that person is good? I'm
two.
wondering, I don't know,
Yeah,
yeah,
it's just for uh, making the user more information. Also, there's a policy about that. One, the human one, the
and I think the problem and the problem so was this so personal analysis I feel is strong behavior analysis that really trust so is important. So I'm not food for thought. but I think really because a lot of I live with these people that it is there's definitely yeah, understanding
Yes, definitely. There are two things. One is there how can you evaluate feedback about there's also something that drives the it's very important.
Um, oh, it's my turn. So actually, let me sort of point out that the last exchanges were, I think, really important. And in fact, um, it's when you and I talk and I ask you the question, so what's your theory? What's your theory of engagement? And I think that really relates to things like figuring out, which phenomena are important, what are the causal relationships, or something. What is it about your account of engagement that would allow you and someone else to predict what would happen were I to put in, let's say, these strategies into a system? So you really need to articulate that level of detail so that engagement is basically more than these sentences that all these other people kind of craft and put into their papers. So what's the science of engagement is really what I feel should be one of your goals. Okay, now there's other things, but let's go to slide 36. Um, so I look at the slide, I'm kind of really puzzled. Um, so when I look at it, I see that irrespective of the bolding that you put in, there's really two things going on. There's human stuff, and then there's all that machine stuff. And things are, so if you in fact took the maxis, uh, then you'll find that basically the one-turn model seems to do pretty good, although it's all kind of bunched together in both manual and automatic instances. But there's something weird about the humans where you actually, I'm not sure what's going on there, but whoever was creating those numbers was basically somehow working with a much larger window. That's 37. Can we go to the previous slide? Yep. And so, so anyway, I look at this and I say there are two kinds of engagement in the world, modulo the 0.01 difference in correlation. So, do you have any idea what's going on here? Okay, if you look at the maxes in each column, they're basically at one turn for the human machine, and there are three turns for the human. Now, modulo the fact that the numbers are kind of all bunched together, kind of the casual observer, which I consider myself to be in this case, is are we looking at qualitatively different types of engagement in the two cases? And why is it, what's up with that three-turn thing that humans seem to cause?
I think it's when we are adding more context, previous context, we're actually adding more features. So I think it's more like a trade-off between the more information from the previous thing and the overfitting of the data. It's like a human, they have, I think think it's like there must be something different.
Well, are you saying there is an engagement and the kind of the reference standard is the human, and one of the things that you actually concretely propose to do is to match the profile of correlations in the first column, because you'll modify and improve your models so that they know how to use mirror history for future.
I think it's just two different models. There's people who behave differently when they're.
And parenthetically, the fact that one turn is the max is kind of useful, because your whole modeling problem gets reduced by 2/3.
I think the difference is not that big.
Well, this is why I keep saying modulo. In any case, kind of the way this stuff you might want to present should reflect that. This kind of leads into another question, which is the feature sets. So you evaluated a whole bunch of feature sets, or sorry, features, and threw out a bunch and kept the remainder. But I noticed all of them really had to do, well, I'm not sure where there's, basically most of them seem to have to do, except for one of them have to do with properties of speech, of speech performance. But the kind of the way you, the framework you present is one that provides a significant role for multimodal features, which include, in particular, face and perhaps gesture and whatnot. So I was wondering what the plan was to figure out if those things, in fact, do anything, and moreover belong in the model that you propose to build engagement. So you do have something like, smiling and laughing, but how's that going to work with the automatic system? What's the plan to incorporate proof or properly define those features and incorporate them into your model?
Basically, we have them. We use some of them like the small
Right. So do you in fact have this feature detectors, if you will, for those things ready? And do you know how they would perform in a model?
Yeah, so we haven't done the real science
And kind of another thing that I was wondering, and over the course of your rather well-organized presentation, is there's engagement, but there's engagement. And in particular, is the kind of engagement you want to find a casual conversational system actually the kind that you would want in an interview system? Now, I know you pointed out that there's probably a core set of engagement strategies that might be general across all conditions, all environments, but there's also these things that are specific. So one question that I guess there's no answer to just yet is, what exactly does that mean in terms of context specificity? But there's this other question of what exactly engagement stuff actually work in this interview thing. Why would it be there, and what's it doing there? I mean, it's there, but how exactly? Well, what's the theory of having engagement incorporated into that environment?
the idea of having engagement in any task-oriented or analysis-oriented, we make sure that the human is in the conversation with us, in order to elicit more information, getting more feedback. I think it's a fundamental metric that all the conversations should be here.
Great. And just one little last question I wanted to ask him because I can. So in your work, is engagement something that you would treat symmetrically? So a lot of what I'm talking about here is picking it up with the human, detecting it in the human, I should say, and then acting accordingly. But what about computers that try to be engaging?
Yeah, so a lot of people think that we have a model of the computer as well, how engaged the computer is. So we have this symmetric thing about mutual attentiveness. I think it's a good idea about this ultimate human AI goal. But I think the ultimate goal of building is my theory, building the recognition of robots. We can elicit the appropriate human responses from the user, like the human. So it's more about that we're trying to. It's artificial intelligence, not really. So we're trying to make sure that we get the same effect from the human, and not necessarily we're saying that the computer should have the same effect that the human is doing. But I think it would be a good idea. So that would be the next step. Once we figure out how to use it, appropriate human behavior, we can say that we can model the computer. I think it's a two-step process. There's kind of other proposed line, but it's me.
I guess I was thinking of it in terms of a strategy. So if I can contrive the computer to somehow come across as engaged um, through the magic of something or other, perhaps that would in fact potentiate the human's engagement.
Yeah, so you mean you want the computer machine to try to trick you, believing that he's
You don't use words like this, but yeah.
Okay.
Okay.
He's doing it again. I need to drop out very soon, but I want to thank you for that nice presentation. I'm going to invite for a couple of meetings later this week so we can talk specifically about the implementation and the next steps. Okay.
Okay, thank you so much, and thank you for being here so early. See you.
Yeah, thank you. Bye.
Sorry.
Okay.
Yeah, sorry. No, I was just reflecting that now we've lost David. But anyway.
Yeah.
Having some
actually David Trump from UFC also came up with the idea of measuring something and evaluating it. Not necessarily can be anything. There are so many assumptions that somehow say that it doesn't really necessarily that is anything. But as long as we have some outcomes that are objective, observable outcomes, then we can say that we're doing it. So one of the things that we said that we're using here, feel for the system of that. This is very objective, human, subjective information that can come through some of the validity. But we also want to have some objective measures. Right? For the non-test, we say how long the conversation is going on. This is very objective measure. The goal is trying to engage in one conversation. The other thing, for the interview training, I think it's, I have to talk to David more about it, but the initial idea of having this training system is that because, because for a lot of people, without experience in technology, including yourself, they're jumping to it for the first time. So if you can talk to a dialog, which requires no money, you can actually get the training, so which benefits the user. It's the motivation thing is that you can to help people find a job. But also, yeah, that will be it. But still, that is it's a learning thing. So some of them may learn from this, but this learning cognitive learning model is very complex. But we can still use that some of the improvement measures. Because some people may learn, some people may not learn based on their motivation and their how they want to how fast they want to jump and how the job is suitable for them based on their previous experience. So the overall idea is to help people to get a job and so that they know familiar with the process of the interview, so they have their expectation when they're going for a real job. So one of the things we can say is we also use a time to help. It helps you to get more right and more confident. Actually,
I like the idea. No.
yeah.
And
So one of the things that I think it might be a good indicator is that we talk about observable behaviors. We also people when they're interacting with do they have more positive social expression? Do they have more? Do they actually talk more? There might be some
system.
to support Adam's point. I actually like the idea of get higher evaluations. Station system with the EPS training system. There's still something dialogue systems that are possible that how does this engagement stuff? So uh, not to say that this is yet what we do, but
Yeah. So
it's a lot.
a lot of people argue that, for example, like standalone systems requesting for flight information, it is isolated in their social context. It doesn't, so you just need to ask for the information, you get the information. It doesn't have any social interaction. It's just like your ask a question, you get the answer. So there's the dialogue thing that in order to, so but why do people still prefer to ask for the human perception compared to the dialogue? It's because the human has this social connection, which is related to, yeah, which related to engagement. But I definitely think it's like a generalized mind model. It should work for other things.
Right.
It should be fucking kind of
And that kind of social collective emotional theory of this stuff anyway.
the theory is that we want to uterine computational engagement that can be, for example, the code engagement. There we can say that it's a robust thing, just like a hit tracker. For different data sources, you might adjust the a little bit, but if you don't adjust it, you can still use it in certain steps. So for different engagement.
Yes, so the mechanics of uh, thing that you alluded to, if at the end you were going to a set of principles that what would you do about introducing
It would be like
and that would be the theory of why engagement.
yeah, generally it's like a recipe. So if you want to get an engagement or what kind of steps that you're going to do. First of all, identify do you need engagement. And then so for your task. And then second is I have a computational engagement model, which is what if you have all the multimodal sensors. Based on what multimodal sensors you might adjust your engagement model. And then we have a set of conversational strategies. Some are generic, some are task specific. You can choose them. And then building from that. And the policy is a statistical policy. So it's not simpler than you can just plug in the head tracker and use it. It's more about that you have to integrate it into your account. So it's a recipe that you have to follow.
Questions? More, less, more, not more. What?
It's catching.
So, you
It's not that. So we're just saying that we find they're correlated somehow with engagement. So it's not that it's like a directly if you find a small, it's more engagement. It's only a contributing factor for engagement. And definitely we say that small, because now we have fusion small and non-fusion small. That takes time and real time. They're also calibration. Most of the stuff we find really more than six. Somehow we get a positive relationship. So I'm just saying that these are indicators. They're not like A happens, B will happen. So there are only some features that we should be taking into account in building the model.
Our second question was what I was right because policy I'm not sure if we um, so
Um, I see what you're concerned about this. Um, so basically, we have two human entities. We're analyzing their data. So we did we have the reference of which we communicated as this file. And then, so it is actually a say it's 125. It's a less complicated intro to see. So mostly we say that once you start and then you have this comparison of higher or low. So this actually helps a lot when we're doing this iteration of engagement and interactive. At first, we only ask them to say, and then it someone we introduce the rest it actually so when people come to their role to talk to people, so we think that's the reference point when you say goal. We say that's the reference point of three. If the next term is higher than the three that we before, which is a lot higher than previous time. So mostly people are ranking from 2, 3, 4. Very few some of the instances you can see are more strongly disengaged when we come to the end. So the range of the selection is actually very limited, which contributes to the high.
Sure, each time
Yeah, yeah, normal. Yeah.
I'm
Yeah.
did you have some given the data used
So, the concept is that normally we ignore them. It's more about that we try to calculate it. So for example, we start with one. We only have one. Have to do the thing. When we finally did it, have to do the then for the second time, we can another. We're not throwing away international one forever. We're once we get there, we come back.
that's
I think because it's we have closer interaction. Yeah, there's it's like usually it's 5 minutes. So because we have like 5 minutes, it's not a lot of Yeah, so this is a very interesting question. When we talk about the small transparent, we're trying to say that we are not measuring, so there's no specific objective that's out of it. So it's everyday chatting. It's like you're using up your hands, you can talk about everything. I agree. Yeah, I agree with you. It's just a little bit different than the traditional concept. Trying to convey that there's different content. Yeah, there's always yeah, it's just like this open domain. It's free based and open domain. It's always
Open domain is already.
Especially when he uses words like,
okay. Yeah. I say it's basically when you calculate the, for example, the number of speech, the mean of the speech intensity of each term, and then you have for all of the difference in the value. You do correlation with the engagement value of that term. Two variables, you use the two. That's very important for you guys to be here. Yeah. Okay. That yell.
yeah, actually, I was going to have an agree because we could set the slide with the schedule on it. So that's one of the things we're going to talk about. Not that you should feel nervous about the fact that you want to look at that slide.
No, we have a